In our last lecture, we discussed about valency band, which is nothing but band occupied by valency electrons, and it is the highest occupied energy band. Next, conduction band, band occupied by conduction electrons, which is the lowest unfilled energy band. And the separation between conduction band and valency band, we call it as forbidden energy gap. Now this forbidden energy gap does not have any allowed energy levels. So once if an electron starts from valency band, it directly jumps into the conduction band. Now depending upon this forbidden energy gap, let us define insulator, semiconductor and conductor. So firstly, let us look at insulator. So insulators are that substances which have large forbidden energy gap, and this energy gap is of order 10 electron volt. So insulators are that substances which have large forbidden energy gap. Now in insulators, valency band will be completely filled and conduction band will be empty. That is, no electron jump takes place from valency band to the conduction band. So if we increase the temperature also, no electron jumps from valency band to the conduction band. That is, there are no conduction electrons for the conduction of current. And the examples of such insulators are glass, wood, etc. But if we go on increasing the temperature, at one particular temperature, few electrons will jump into the conduction band from valency band. So depending upon this only, we got semiconductors. So semiconductors are that particular substances which have small forbidden energy gap. And now here valency band will be either partially or completely filled, and conduction band will be partially filled. So at lower temperatures, all the electrons in a valency band are tightly bounded to the nucleus. So no electron jump takes place from valency band to the conduction band. So at 0 Kelvin temperature, this substance completely behaves like an insulator. At 0 Kelvin temperature, this completely behaves like an insulator. Now let us go on increasing the temperature. At nearly 300 Kelvin temperature, slowly the electrons starts jumping into the conduction band from valency band. That is, here after 300 Kelvin temperature, the substance is behaving like a conductor. When electron jumps from valency to the conduction band, we get free electrons in conduction band, and that free electrons give rise to the current. So at a 0 Kelvin temperature, it behaves like an insulator, and from 300 Kelvin temperature, it behaves like a conductor. So semiconductors are that particular devices whose resistivity lies between a insulator and a good conductor. And in such semiconductors, we will have small energy gap. And the examples of semiconductor are germanium and silicon. Now, if in take the case of germanium, the energy order of forbidden energy gap is 0.7 electron volts. For silicon, forbidden energy gap will be equal to 1.1 electron volt. Now next, let us move for conductors. So now in case of conductors, we don't have any forbidden energy gap. That is, valency band overlaps with conduction band. So here there is no forbidden energy gap. No forbidden energy gap. So valency band and conduction band overlaps with each other. So as they are overlapping with each other, that is, as there is no forbidden energy gap, there will be no structure for the formation of holes. For formation of holes. So totally we will find only free electrons, and these free electrons are responsible for the current conduction. So conductors are that substances which contain plenty of free electrons for the current conduction, and conductors are that particular substances in which there is no forbidden energy gap. So if forbidden energy gap is large, we call it as insulator. If forbidden energy gap is small, we call it as semiconductor. If there is no forbidden energy gap, we call it as conductors. Now let us move to semiconductors. So semiconductors are divided into two types. One is intrinsic semiconductor. So this we also call it as pure semiconductor. Other is extrinsic semiconductor. We also call it as impure semiconductor. Now this extrinsic semiconductor is again classified into two types. One is P-type extrinsic semiconductor, other is N-type extrinsic semiconductor. Okay, so semiconductors are again divided into two types. One is intrinsic semiconductor, other is extrinsic semiconductor. Extrinsic semiconductor is again divided into P-type extrinsic semiconductor and N-type extrinsic semiconductor. So before moving to P-type intrinsic semiconductor, let us discuss about the chemical bond formation in semiconductors. Okay, let us discuss about chemical bond formation in semiconductors. Now for this I am taking the example of germanium. The atomic number of germanium is 32. In this 32 electrons, 28 electrons are tightly bounded to the nucleus, and 4 electrons are present in outermost orbit, which we call it as valency electrons. Right? Now these 28 electrons which are tightly bounded to the nucleus lie in innermost orbits, and these 28 electrons form a iron core. The circle which I am drawing is nothing but iron core, positive iron core. That is, these 28 electrons which are tightly bounded to the nucleus, which are in innermost orbits, form positive iron core. Now next, to this iron core only the 4 valency electrons are attached. The 4 valency electrons which are present in outermost orbit are attached with this iron core only. Now Let us bring another germanium atom nearby the first germanium atom. Right? The circle which I draw is nothing but the positive ion core formed due to 28 electrons which are tightly bounded to the nucleus. And these are the 4 valency electrons attached to this ion core. Right? Now, there will be a force of attraction between the ion core and the valency electron of the next germanium atom. Similarly, this germanium atom's ion core also attract with the valency electron of the first germanium atom. So, in such a way, 2 electron pair is formed. In such a way, 2 electron pair is formed. And now, here electron pair is formed when the repulsive force between ion core balances by the attractive force between ion core and valency electron of neighboring germanium atom. A electron pair is formed, and this bonding we call it as covalent bond. In such a way, covalent bonds are formed between germanium atoms. So this is about chemical bond formation in a semiconductor.